Hello everyone, welcome to IGCSE with Optimus. Subscribe to our channel and hit the bell icon to never miss an update on our IGCSE content.
Hello dear students. So today we are going to talk about question number 7 from paper 2019 October-November 42. Question is related to electricity and magnetism. Question says that figure 7.1 shows a coil of wire wound on a thin plastic cylinder. The plastic has no effect on any magnetic field. The galvanometer is extremely sensitive. I hope you know that galvanometer is a device which helps you to measure smaller values of current. Ammeter is for significantly high values of current. Galvanometer is for very small values of current, measuring very small values of current. You can see the diagram over here. There is a coil, okay, which is connected to galvanometer over here. So this is our galvanometer, and there is a track over here wherein you can see there is a magnet kept. They have said a magnet is fixed on a small trolley that runs without friction on a track through the cylinder and coil. The trolley is released from point A, so it runs through the coil from right to left. So it starts moving from here and it travels downward. Okay. State and explain what is observed on galvanometer. So understand this magnet is going to have field lines. Okay. So we know that the field lines, they start at north and they end at south. So there are going to be field lines on this magnet. When the magnet runs through the coil is going to cut these field lines. And we know that whenever field lines are cut, the magnetic flux occurs and EMF is induced. Okay, I repeat, whenever field lines are cut by the conductor, the EMF is induced. Whenever EMF will be induced, the galvanometer is going to show some deflection. So that they are asking, state and explain what is observed on the galvanometer. So you will say that galvanometer shows deflection. Means the pointer on the galvanometer will show some deflection, indicating that there is current induced in the wire. So galvanometer shows deflection. We'll continue with the reason. This is because as magnet moves through the coil, the EMF is induced. Okay, next. The trolley is now released from point B. So it runs through the coil from right to left again. So initially we had kept it over here. Now we have kept the trolley over here. It's going to start from position B. State what is observed on the galvanometer and explain why it is different to your answer in A1. You can understand if we consider this as a ground, okay, then from this ground, point A is over here, whereas point B is over here. So point B is higher than point A, so there will be greater gravitational potential energy for the magnet when it starts moving from here. This gravitational potential energy, greater gravitational potential energy, will help magnet to achieve greater speed as it falls down or runs down through the wire. We know that the induced EMF or current depends on three factors, that is B, magnetic field of the magnet, L, the length of the conductor, and velocity V of the movement of coil or magnet. As the velocity of the velocity of the magnet will be greater when it runs from point B, the more number of field lines will be cut per unit time, and hence the induced current will be greater. If induced current will be greater, the deflection will be greater. So they are asking, state what is observed on galvanometer and explain why it is different to your answer in A1. So you can write galvanometer shows greater deflection, when magnet starts from B, it travels at higher speed, hence more field lines are cut per unit time. As more field lines will be cut per unit time, the deflection will be greater because the induced EMF will be greater. Part B of 7th question says that figure 7.2 shows an extension LED used to supply power to a 3 kilowatt electric heater on a cool evening. State and explain 3 dangers with this arrangement. Now you can see the diagram. In the diagram you will see many faulty arrangements. The first thing is the wire, it is lying on the grass. Expecting that grass will be damp, wet, it will cause electrocution or short circuit. Second, you can see that they have said there is a cut in outer insulation. Cut in outer insulation will cause leakage of current, which will again lead to the electrocution. Then the extension LED designed for use with a 25 watt lamp. Okay, so the capacity of this LED is only for 25 watt lamp, and what we are connecting to that is a 3 kilowatt electric heater, means a 3000 watt device to a 25 watt supply, you can say. Okay, so we will be writing these 3 points as dangers in the arrangement. The first can be the wires and plug are on damp grass which may cause electrocution. We can say that the extension LED of capacity 25 watt is connected to 3000 watt heater, which may cause overheating. We can also see the third danger over here, that there is a cut in outer insulation. So cut in insulation may cause leakage of current leading to electrocution. Question number 8. It is about electricity and specific resistance. The question says that a wire of length 2 meter and a cross-sectional area of 0.4 millimeter square. So we are given with length, we are given with area of cross-section, has resistance of 0.14 ohms. Calculate the resistance of another wire of same material of length 3 meter and area of cross-section 0.90 meter square. Now here we are talking about 2 different wires, meaning with different dimensions but made up of same material. When I am emphasizing on same material, it's a very important key to solve this question. Pay attention. A wire of length 2 meter. So we will take this as L1, first wire's length. This is area of the first wire and this is resistance of the first wire. Calculate the resistance of another wire of same material. Okay, so I'll just underline this. It says it is made up of same material of length 3 meter and area of cross section. So I'll take this as L2 and area of cross section 0.90 millimeter square. So that is second area. Now the key to solve this question is wires of same material will have same value of specific resistance. Specific resistance is indicated by letter rho, and the value can be calculated using formula R into A upon L, where R is resistance, A is area, and L is length. Now, what we can do here, pay attention. We know that these two wires are made up of same material, so they are going to have same value of specific resistance. So specific resistance of first wire is equal to specific resistance for the second wire. So rho 1 can be given as R1 into A1 upon L1, and rho 2 can be given as R2 into A2 upon L2. While by substituting the values, we can write for R1 0.14, for A1 we can write 0.40. Since millimeter square will get cancelled, we don't need to convert it. Divide by L1, L1 is 2 meter, is equal to R2 is what we have to find out, into A2 is 0.90 divided by L2, L2 is 3 meter. Now when you will calculate further, you will get the value of R2 as, first we will calculate the left hand side, 0.14 into 0.40 divided by 2, the answer will be 0.028. So 0.028, you can multiply 3 on this side, so 0.028 into 3 and divided by 0.90. Divided by 0.90, your answer is 0.093. So the final answer is 0.093 ohms. The next question is about digital electronics and logic gates. A student is designing a digital electronic circuit. Figure 8.1 shows her partly completed design. Okay, so this is partly completed design. Table 8.1 is a truth table. Complete the columns in this truth table to show the values for input B in the circuit. Firstly, what two gates we can see over here? See, this is the symbol for OR gate and there is a bubble over here. So this is nothing but NOR gate. And this is the symbol for AND gate. Okay, so what is operation of AND gate? Multiplication. What are the two inputs for AND? It is A and B. So it's going to be A into B. And that gives us the output D. So whatever values you are seeing over here, they are by multiplying A and B. We already have the values of A and we have the values of D. From that we can find out what will be the values for column B. Now for that you need to remember the operation of AND gate. It gives you output 1 only when both of your inputs are value 1. Okay, so here one of the input is 1 and the output is 0. Okay, so surely the input for B has to be 0. So 1 into 0 will give you value for D 0. This is second input in the second row, or A it is 0 and point D is 0. Now it can be multiplied by 1 or it can be multiplied by 0. Okay, so for that we can check your NOR gate output. So if I put 0 over here, then it will be for NOR gate 0 from A, 0 from B, 0 plus 0 will be 0 and complement of that will be 1. But here you can see they have given 0. So by default this has to be 1. Now see, 0 into 1 will be 0. 0 plus 1, I am talking about NOR gate, 0 plus 1 will give you 1, but its complement will be 0. So C's output is 0. So this one is correct. Then here you can see for point D, they have given output 1 and input A is 1. By default, B has to be 1. Then only the output of D can be 1. 1 into 1 will be 1. And then for last, here they have given 0, here they have given 1. We already have explained the scenario over here, so here it has to be 0. 0 into 0 will be 0, and 0 plus 0, the addition is 0, but its complement for NOR gate will be 1. So for C, the output is 1. So what values we have got for input B? 0, 1, 1, 0. Now, the column O in the truth table shows the desired output values for the circuit. On figure 8.1, complete the circuit to achieve these output values. Label any gate used. You can see the output O is going to have inputs from C and D. Okay, so we have to see the column C and D and check the output of O to decide which gate is over here. So first I'll start with OR gate. Okay, so for OR gate, 0 plus 0 will be 0, but here we are having 1. Okay, so OR gate is not an option. For AND gate, 0 into 0, it has to be 0, but here they have given 1. So AND is also not an option here. So it either is going to be NOR gate or NAND gate. Now for NOR gate, if we add 0 plus 0, it's going to be 0, and the complement of that, remember we are talking about NOR. So 0 plus 0 is 0 and the complement will be 1. So that stays true. The second row, 0 plus 0, the complement will be 1. Again, the second row proves that it still can be a NOR gate. 0 plus 1 will be 1 and its complement is 0. Still it is true that it can be a NOR gate. And 1 plus 0, 1 and the complement is 0. So now we are confirmed that this is going to be a NOR gate over here, similar to this one. So we can indicate it like this. Okay, C is one of the input to this NOR gate and D is another input to this NOR gate. So what type of gate is this? NOR. They had asked us to label this gate, so we have written NOR over here.